Hello, hi everyone.
Hi, Aline.
How are you, Ravali?
Good. How are you?
Good, thank you for asking. What is the difference between LAN and WAN? Anyone can answer. What is the difference between LAN and WAN? Ravali, can you answer it, please?
One second, Aline.
Okay.
So, sorry, what's the question? LAN and WAN, right?
Yes.
LAN is, local area network, which helps to, communicate like in a single building or in a, in the same campus, like or in the same office, like that. So but WAN is like a wide area network which helps to communicate like in different cities or like different countries, like that, like in different geographical areas.
Good. Precisely, what is the networking? Can you brief about what is the networking?
Networking is nothing but communication between like two different clients or users. Like it mainly refers to like interconnected computer devices which can exchange data or else resources. They use mainly protocols to transmit this information. Like they may be wireless technology or physical.
Okay, fine. Good. Any questions, guys? Yesterday, what we discussed? Any question? Anyone? Sayasri, Ravali, Udit, Victoria, Cycling, anyone? Any questions?
No,
No,
Uh,
Aline.
can we start new topic?
Yeah.
Okay, fine. Good. Yeah, today's topic is our OSI model. Okay. OSI stands for Open System Interconnection. And it is a uh, reference model actually. It is a reference model. For implementation part, we have a TCP IP model. Understood. It is a only for reference for human being understanding purpose. It is a our reference model, and we have another model for engineers, network engineers. That is for TCP IP model. It's implementation. What we are doing, network engineer will do. That is for implementation purpose. Okay. For here we'll discuss OSI. There we have it consists of 7 layers. It consists of 7 layers. What those are? Application layer, presentation layer, session layer, and transport layer, and data link layer. Okay, right here. If you want notes, you can prepare the notes. Okay. OSI consists of 7 layers, like your application layer, and presentation layer, layer save layer 5 is it's layer 5, it's layer 7, layer 6, and it's layer 5, that is session layer. And part of the OSA model of layer 4 is transport layer. And we have another, it's layer 3 is for our engineer will work on layer 3, layer 4, and layer 2 and physical layer. Apart from that, we have like a data link layer. Last one is physical layer. Now, more to the, we'll discuss here. Our network engineers will work up to, this is for software engineers will work. And apart from that, these 4 layers, layer 4 and layer 3 and layer 2 and layer 1, these all are for our network engineers work here. Now more to the, we'll discuss about physical layer, more brief about physical layer. And the physical layer mainly, it is kind of a media in between the two PCs. You can assume like here I have one PC, it is connected to other PC, directly connected. Here the media is like cable. This between RJ with the help of NIC card will directly connected to PC1 to PC2. I'll will discuss about more about physical layer, then we'll move to this topic. Main functionality are here in physical layer, like a physical layer requirements here. Just right here. It deals with physical transmission to of binary data on the given media or copper or wireless, like right here. It deals with physical transmission of binary data on the given media, whichever we have mentioned here. This kind, it's kind of media, the cable connectivity in between PC 1 to PC 2. Like if I connected, it's kind of copper with the help of copper cable. The copper cable and electrical signals will be transmit here. And if I have connected with any Wi-Fi devices, there we have like signals like radio signals in between us. PC, if this PC, one more PC is there here. can assume this is PC3, where like the connectivity like Wi-Fi. It's radio signals. Basically, in physical layer, it will be work like what machine will understand like zeros and ones, right? The physical layer will be the machines will understand 0, 1, 0, 1 because it's a machine language. Human can understand verbally whichever data is there, he can understand, but machine won't understand these words. That is the reason behind of this we have a media like wireless media, fiber media. These all are will work like bits. Okay, physical layer will generate what we call its bits. Okay, it will be bits. The data format is like bits. The data format is bits. Here we have copper media, fiber media, and wireless media. Up to here, any doubts?
No.
Write this point also. It is also deals with electrical signal, mechanical, and functional specification of the devices and media. What we discussed here, same thing. And the major function described in this layer are encoding and decoding the information. The major function of this layer are the major function described at this layer are the information will be encoding and decoding. Like I'll explain. Coding and decoding, it will be format will be bits, right? Here format is like bits. The format is like machine can understand zeros and ones. If I am sending one information like to this different pen. See, I'm sending here hi, hi from using PC1 with the help of copper cable, copper medium. Then PC2 receive the information with the help of copper medium. When I am sending hi to this PC, then it will be received that hi. On which format? The format is encoded and decoded. Encoded means hi here 0, 1, 0, 1. This format, that is PC will receive this format, then PC2 whenever this PC receive that time it will be decoded. We'll discuss. Wait a second. Like the data flow here, actually, whenever the sending the information, this PC like user is sending. Whenever we are using application layer, the data will be likewise. Whenever the receiving that time, the data will be first. It will be moved to physical layer, then data link layer, then network layer, then transport layer, then session layer, then presentation layer, then application. Whenever we'll reach application layer, then that time you reach you understand what is the encoding and decoding. Till now just you can assume like we are here encoded the information like 0 and 0101 machine level language. Up to here, any queries? Please, if you have any query, just tell me. Up to here, any queries? And fine. See, copper media, the electrical signals are different voltages, and fiber media, light pulses of different wavelengths, and wireless media, radio frequency. It's converting binary data into signals based on the type of media. Understood? And in physical layer, we have like which kind of devices we'll use. In layer one, we have some devices also, and which kind of signals. Mode of transmission, here we have different mode of transmission. Guys, if you are not understanding, just let me know. Mode of transmission. Here we have three different types of communication mode. Three different type of communication mode in physical layer. Those are like simplex, half duplex, and full duplex. Three type of mode of communication happen in physical layer. That is like simplex, half duplex, and full duplex. We'll discuss here what is simplex, what is half duplex, and what is full duplex. In simplex mode, the data transfer only one direction, not even two direction. The data will be flow like only one direction. It will not like unidirection. It won't. It won't. Not at all. Okay. But in half duplex, the data transmission will be PC1 to PC2 there at a time only one direction, not it simultaneously. Not it simultaneously. It data can transfer, bits can transfer at only one direction, either receiver or transfer, not at both at a time. But when the full duplex mode, that time the data can be transfer, the frames will be for transfer at both direction simultaneously at a time. Receiver and sender at a time, both direction. And in physical layer, we have different types of devices work here. In this physical layer, here, which kind of devices work? Guys, any doubts up to simplex, half duplex, and full duplex?
All clear.
No. Okay, good. Ravali, can you tell me what is half duplex?
Oh, the mode of transmission, like for which transfers between two PCs, like from one to other and other to like back.
Okay, it's not like simultaneously, right?
Like I didn't understand.
What is half duplex? The data flow will be like simultaneously send and receive at a time, or it will be send only one time and receive after then that.
Send and receive. I mean, send at one time and receive later.
Okay. And Ajay, what is a full duplex?
You can send messages simultaneously
Good,
from OPC1 to PC2.
good. Sai Sri,
Yes,
what is simplex?
transmission is from one to other, only in one direction.
It always only one direction, not receive, only send always.
Only one direction.
Yes, good. It's simplex, half duplex, and full duplex. Good. And here we have different mode of devices. Which devices will work in this physical layer? Hub, a repeater, or cable modes, like we have NIC cards, something, right? Those are the cable, whichever we are plugged in cables, those are there. And hub, it's like a extension box. It is not an intelligent device. It like only send the information. It is lazy kind of device. It will be send, otherwise receive the information. It is kind of half duplex device. It work on half duplex. And repeater also same thing. It's kind of devices only. Nowadays we are not using repeaters. And transmission media is like copper media, fiber media, wireless media. These are the devices will work. This is the media. This is all about physical layer. Here will generate bits. The information is like bits, 0 and 101. This kind of information will be happening. Any doubts till up to here? If you have any doubts, not it subject related, also ask. Silly doubts. Anyone? I hope no doubts. Okay, we'll move to the data link layer. And data link layer is basically layer 2. Layer 1 is our physical layer, and data link layer is data link layer. Here we have the information like it is responsible for the end-to-end delivery data between devices, LAN network segments. It is taken from the upper layer and transfer to the down. The information from taken from the up layer, that is network layer, layer 3. The segment whichever we are getting, those are here. And data link layer compares of two sub layers. Here we have two sub layers, like everyone know, I think MAC address, based on MAC details only data link will work. It's unique to the device. Media access control, MAC stands for media access control, and it deals with hardware address. Every PC, every device having unique MAC address. It is standard by the companies. It deals with hardware addresses, MAC address in the sense, and it provides reliable transit of data across the physical link. It will be whichever data it's getting with the help of MAC table. For information, bits will be converted to the frames, and in we call here packet, we call it here whichever information that is like frames. Frames. And here will example of devices like Ethernet. The connectivity is like we have devices in the sense you can assume like it's connectivity between the device, that is like we'll discuss Ethernet. And token ring also is there, but it is old technology, we'll not discuss, and we'll discuss now here. The here, first of all, the Ethernet cable connectivity between these two PCs. Physical connectivity. First, physical connectivity, it will be fine. Then PC1 wants to know, wants to communicate. PC1 wants to communicate PC2. Then, guys, if you are the meeting ended, then please join the same link. Here, like MAC address is, its MAC address is actually 12 bits, 2 to the power of 12, in the sense we have 48 bytes of information. Okay, 48 byte. Sorry, 12 digit of hexadecimal number, that is 2 to the power of 12. Then we'll get the whichever value 2 to the power of 12 power of 12 is equals to whichever value we'll get, that is like our MAC address, but we have like 48 bits of hexadecimal number. Bits of hexadecimal number, that is like here we need a, a, MAC address. And first 24 bits are organization unique identifier, and after then 24 bits of information like it's 48 means 24 bits is organizational unique identifier, and after then 24 bits are like vendor assigned. Okay, for example of MAC address is likewise, and this PC having MAC address BB. PC1 wants to communicate PC2, that time we have like IP address will move to the next level. Once we'll get first, they both share the MAC table. If the PC1 knows the PC2's MAC address, then only the information possible to send. It will be happen in with the help of ARP. ARP here layer 2 protocol is ARP. With the help of ARP, we will find out that information. We'll discuss later. And here one more protocol. I said two protocols work in this layer. Those are, first one is MAC address, second one is LLC, logical link control. It will be connected to the, this MAC address is connected to the down level, that is L1. Then logical link control is connected to the above layer, that is network layer. Okay, it deals with layer 3. Please prepare your notes, everyone. If you want, you can take this screenshot. It deals with layer 3. It provides communication with network layer. Understood? And here devices will work. Which devices will work in this layer? In sub layer. Because this device is connected to the network layer. So here we have switches and bridge in the sense switch only again. Earlier we call it as a bridge. Now we call it as a switch. Understood? When we are discussing here STP, spanning tree protocol, that time you can assume like bridge in the sense switch only. And NIC, network interface card. In your laptop also, just check it here. One RJ45 connector is that is your network interface card, NIC card. And how it will be connected to layer 3? Here, the PC, we have end users like so many end users, and these end users are connected to one switch. It's a switch. This switch is connected to L3 device. This one is our router. The connectivity will be happen likewise. The connection. This is our LAN. These all are L1 devices, you can assume. This is for L1 and L2 and L3. Now we'll discuss L3. Up to L2, anyone have any queries? Please ask. If you have any queries, ask me. And here switches connected to routers, and the LLC, logical link layer, is connected to the logical link control is connected to routers, that is our L3 devices. It will be deals with L3 devices, logical link control. And media access control is deals with end users. Apart from that, switches also, it will be deals with switches also. And because in L2 will work here switches with the help of switch only. Will get our IP address. Because they won't directly connected. For your understanding purpose, I explained likewise, but switch is required. Switch is required in between. I hope guys, everyone got up to here. Any queries? Data link
No.
layer. Just think, if you have any queries, we'll discuss. Data link layer consists of two sub layers. If the link, the Zoom meeting will be end, please join the same link. And we'll move to the transport layer. Up to here in routes, transport layer. It is the responsible for end-to-end transmission of data across the multiple networks. It is responsible for end-to-end transportation of data across the multiple networks. If we have like here, I have one PC here, one switch here, and one switch is here, and they both are connected to one router, and they are connected to some end users. These are connected to some end users. A router, mainly it will work to different networks. Okay, router will work to different networks, but switch will work within a network. Switch will work in within a network, but router will work in two different networks. Please join again. The link will be ended now.